What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to calculate the pH of a solution after 0.02 mole of HCl is added to 1 liter of 0.1 molar propanoic acid solution, which Ka is 1.3 times 10 to the power of negative 5. So we have propanoic acid solution, which is HC3H5O2 plus water. It's gonna produce H3O plus C3H5O2 minus. We have initial, change, and equilibrium. Initially we have 0.1 molar of acid. This one 0, this one negligible, this one 0 as well. But since we are adding strong acid, 0.02 mole per liter, it means that this one is going to dissociate completely, and the concentration of proton right in the beginning is going to be 0.02. So we have 0.1 here and 0.02 here, plus 0. Initially we have nothing in here for the conjugate base. Then change is going to be negative x plus x plus x. That will be 0.1 minus x, 0.02 plus x, and plus x. Then Ka will be 1.3 times 10 to the power of negative 5, 0.02 plus x times x divided by 0.1 minus x. So now what we can do, we can neglect x comparing to 0.1 and 0.01. So we cancel that. And x will be 0.1 times 1.3 times 10 to the power of negative 5 divided by 0.02. That will be 0.1 times 1.3 times 10 to the power of negative 5 divided by 0.02. That will be 6.5 times 10 to the power of negative 5. Which makes sense because that's completely smaller than 0.02 and comparing to 0.1. So the concentration of H3 plus is going to be 0.02 plus 6.5 times 10 to the power of negative 5 in reality, but since this one is much smaller than this one, we can say that's approximately equals to 0.02. So pH will be negative log 0.02. That will be 1.7 or 1.70. That's the pH of this solution.